Hello, I'm just going to do a quick, well, I'm saying quick, I don't know if it's going to be a live code, so we'll see. I'm just going to have a look at this centered average thing and see if we can do it in like Java by refactoring and moving it over. So let's share screen. Let's turn this stuff out of the way. So we did a centered average in class today. Let's grab this here. Look at what happened during that. So we've got this doing the smallest and largest. Theoretically, that should min and max. I believe there's one of those in Java. So let's see what happens. So let's make a new project. Call it I don't know, a average project. Let's finish that. Don't create a new module. Let's just create manually new class. Call it centered. Why not? Okay, so we've got our centered. Let's now do our def thing and all that crap. Let's have a look. We've got a load of stuff here. So instead of defining, we'll do like a static centered average that takes in ints. What does it take in for ints? We want it to take in a, I don't know, int array of ints for now. Yeah. We need a return type, so we need it to return something. Public static, it's going to return an integer. Okay, so let's change these about a bit. Let's change it to that. Let's do that. Let's refactor this. I think math.min should be a thing, and then math.max. So int smallest and int largest of those. Let's do that. Let's get rid of some of these. Let's move these up a bit and do like a term that's in about the whole. Now let's add the semicolons to keep it correct. Min and max, change a sign and a thingy. That's not very useful. I'm pretty sure there is a Java min and Java max. So it needs to take in, so it doesn't take in an actual list, which is rather annoying. So we're going to have to figure a way around that. Yeah. So that's not doable in that sense. Let's look at min. What does it take in? Math's not an applicable argument of int, so it can't take in things like that. So let's take a look. Java max of a. I have to make a new function. Right, okay. We're going to have to write a max value and a min. It's going to be interesting. So that's rather annoying. Okay, so much for using built-ins. All good fun. So let's say we have a static int max val for now. It takes in that. Okay, so we've now got this thing that returns an integer and takes in a thing. So we're kind of overriding what we want here. So we're going to call like min val and max val. Obviously, this isn't necessarily what we want yet, but we'll do the same sort of thing for this. There may be some built-ins that we can use. I'm just gonna int max is equal to ints at 0 to start with. So we'll get a sentinel value there. Then I'm just going to loop over the stuff. So for int ptr equal to 0, so our actual starting pointer there, we're going to then say while our ptr is less than int.length, we're going to do ptr plus plus. So there's our little for loop. We're going to loop over these things. So then we're going to say if our ints at ptr is greater than, greater than our max value, then we want to swap them. So we can set, well, we'll set our max value equal, not swap them, set it max equal to ints at. There we go, and then we'll just return the max at the end of all that. Okay, so that's a max one. We can do the same for min. Just copy this, and it's just using slightly, literally the opposite type of thing. So instead of max, we'll say min and min. Mim. Oh, that's not good. Min. Min. And instead of greater than, we'll go less than. Return min. So we've got a maxing and a minning function there. Hopefully that was fairly straightforward to follow. So we're calling those to get those values. That was an extra step that maybe I didn't want to have to do, but it's just one of those things. We'll deal with that. So now we can sum stuff. So let's say, okay, we've done that. Now let's sum the stuff. So let's make a new int value of sum, following the same sort of procedure, starting at 0. Then we're going to loop over it. So we'll say for I equals 0, or I is less than ints dot length I plus plus. Okay, so we're going to just go over all of those. So here's where we're going to have to extract it because that's the index. So what I'm going to do is I'm going to do sum plus equals ints at I instead. So sum plus equals ints at I. Keep adding those to it. So it's following the same sort of algorithm here. So we've got to that, we've got that done. Next we can subtract smallest and largest, which is what we wanted to do anyway. So we can actually say, okay, once we finish doing that and we've ended up with our sum, we can just do that subtraction now. Did I call something largest? Yeah, that's fine. And then set our end result to a floor division. Now, I don't know whether we can do a floor division directly, so we'll kind of figure that out now. There probably is one somewhere, but let's just do this. Result equals sum divided by length of int, so we can't say that. Ints dot length. So let's see if it allows that. That theoretically should coerce it into being an int anyway, and floor it out eventually. And then return our end result. So instead of returning one, we'll return our end result. Now, just out of interest, let's see if that actually works. Let's try that. Yeah, we've now got this crazy little refactor and changeover to be. We've added our little helper functions or methods of max val and min val. Now let's see if it works. I mean, it theoretically should. It's kind of the same algorithm, right? main function. It's the entry point of the application. And let's say do it this way, or is it? I can't remember using C style. It's been a while since I've done Java, so I'm a bit rusty on this. 23, 12, 1. Well, let's do it in the sorted order first. It doesn't really matter, I suppose. 23, 12, 1, 3, 4, 5. Well, actually, let's actually do it utilizing the same test cases that we know does stuff. So let's utilize our numbers with the same thing. So where's one that we know should do something? Let's try that one first. We know that should theoretically return 3. Let's see if it's broken or whether the implementation just works. So let's take that as a test case and utilize that as a test base there. We know that theoretically that number's, if we do a centered average on that, should return 3. Well, let's see if it does. So system dot print line. No, not print. Damn it. And we're going to say, what do I call it? Centered AVG 1. On numbers. Let's see whether this breaks or whether it just works or what it does. Yeah. Let's run it. 3. So we've got the same algorithm working because we were able to extrapolate and work it out as a problem set and make an algorithm. It doesn't matter about what language we use. It just works. I mean, that's all I kind of wanted to go over. So hopefully that makes sense. It's language agnostic. That's the idea behind it. So thanks a lot, guys. I'll see you again.